Today we are going to discussing about physics firstly concerning about the topic thermal expansion. And this topic of thermal expansions contains about the several subtopics. The first one is the concept of thermal expansion. The second one is the thermal expansion of solid. The third one is by metallic strip. The fourth one is the thermal expansions of liquid. And fifth one is anomalous behavior of water. Then the sixth one is thermal expansions of gas. And seventh one is the gases law. So in this topic of thermal expansions, we are going to discussing about the concept of thermal expansion. By the way, thermal expansion. Thermal expansion is the tendency of matter to change in volume due to change in temperature. The process or the behavior of matter to change in volume due to change in temperature is what we call a thermal expansions. Kwamba tabia ya maada kubadilika state yake, kuchange state yake, kuchange hali yake kutoka kwenye hali moja kwenda kwenye hali nyingine, ambapo inahusiana na change in volume, kuongezeka kwa volume. Hii inasababishwa na fact ya change in temperature. As the change in temperatures occur, it means that the changes of volume occur. That's why we say thermal expansion is the tendency of matter, kwamba hii ni tabia ya maada to change in volume, kubadilika kwa volume due to the change in temperature, kutokana na change ya temperature. So there is a various terms used in thermal expansions. So the terms used in expansion in thermal expansion is expansion. What is the expansion? Expansion is the process whereby the object increases in volume due to the increase in temperature. Kwamba hii ni ile tabia ya mada au vitu fulani au ni ule mchakato ambapo object inaongezeka volume yake kutokana na kuongezeka kwa temperature yake. So expansions, it means that the increase in volume due to the increase in temperature. Kwa material fulani tukiongeza temperature kwenye yale material, volume yake inaongezeka. So kile kitendo cha material kuongezeka kwa volume yake due to the increase in temperature is what we call expansion. Another thing is the contractions. So the contraction, what does it mean about the word contractions? So contraction is the process whereby the object decreases its volume due to the decrease in temperature. So kile kitendo cha object kuongezeka kwa volume yake kutokana na ongezeka kwa temperature yake is what we call contraction. The mechanism in which the object decreases in volume due to the decrease in temperature is what we call a contractions. Kwa mantiki hiyo ni kwamba contraction ni kile kitendo ambapo object inapungua volume yake kutokana na kupungua kwa temperature. There are various sources of thermal energy. As we discussed earlier kwamba thermal energy yenyewe inakuwa ndo fact ambayo inasababisha increase or decrease in temperature. What are those source of energy? Ni zipi hizo source of energy? The first one is the sun. The sun is the one that provides us energy. That we call it temperature. The sun generates its energy by nuclear fusion. So the sun is the one that generates energy by nuclear fusions. Whenever there is a nuclear fusions occur, the sun is the ones who generate that one. Another thing, source of energy is the combustion of fuel. The burning of fuels bring about the heat. The burning of fuel brings about the energy. That energy are in form of heat. Kwamba kuungua kwa fuels, mfano petroli, kerosene, diesel is the one that cause the thermal energies. Another thing, the nuclear energy. The nuclear energy is the energy generated from the nuclear reactions. Kuna kitu kinaitwa nuclear energy. Hii nuclear energy ni nguvu za nuclear zenyewe huwa zinapatikana kutokana na nuclear reaction. Whenever there is nuclear reactions, there is occurrence of nuclear energy. Another thing is the geothermal energy. The heat energy derived from the Earth's core. All of us, we understand about the Earth's core. So within the Earth's core, there is some energy. That's what we call geothermal energy. Kwa mantiki hiyo kubwa ni kwamba geothermal energy, hii ni energy ambayo yenyewe inakuwa obtained or generated from the Earth's core. So another thing is why substance expand. Kwa nini vitu vina expand au kwa nini vitu vinaongezeka ukubwa wake au increase in volume inatokea? The very simple answer is because substance expand when heated, kwamba substance huwa ina expand au huwa inatanuka wakati ambapo tutakapokuwa tuna ihiti. On how? When heated, because it is particles vibrate more rapidly, kwamba tutakapokuwa tuna heat particles zake zitakuwa zina vibrate more rapidly, kwamba particles zake zina vibrate haraka haraka. So due to the particle vibrations, as a result they collide and push each other further apart. Kwa zile particles zinapokuwa zina collide zinakuwa zinasukumana further apart, tokea mmoja kwenda mwingine, anamsukuma mwenzake, sukuma mwenzake. All states of matter, solid, liquid and gas expand when heated. Kwamba cha kuzingatia hapa ni kwamba state zote za maada, either solid, either liquids, either gas, hizo zote zina expand when heated. Whenever we apply heat, those states of matter expand. Explain another thing. Explain what's happening when liquid or gas are cooled. Kwamba eleza kitu gani kitatokea pale ambapo solid, liquid na gas zitapozwa. Tunasema when the solid is cooled, wakati ambapo solid itapozwa, it is molecule lose kinetic energy. Zile molecule zake zitakuwa zinapoteza kinetic energy. Tulisema molecule ni nini? Molecule is a collections of atoms or groups of atoms. Kwa mkusanyiko ule wa atom is what we call molecule. So when the solid is cooled, wakati ambapo solid ile itapozwa, it is molecule lose kinetic energy. Molecule zake zitapoteza ile kinetic energy and have less vibrations. Kwa mantiki hiyo sasa, ikipoteza kinetic energy itakuwa na less vibration, vibration yake itakuwa ni kidogo. As the vibrations become lower, as wakati ambapo tunasema vibration inapokuwa kidogo au inakuwa chini, the molecules are pulled closer, kwamba zile molecule zinakuwa kuelekea kuwa karibu zaidi. So as the molecule pulled closer, the solid contract slightly in all directions. Kwa mantiki hiyo, ile solid material itakuwa ina contract, inasinyaa kuelekea katika all directions. Thereafter, there is another questions here. Explain what happens when solid, liquid or gas are heated. We have previously said when we heat those, the molecule gain kinetic energy and vibrate more vigorously. As the vibrations become large, the molecule are pushed further apart and the solid expands slightly in all directions. Another thing is the expansion of solid substance is so small such that it is difficult to observe its change. Kwamba tunazungumzia expansions of solid. So kwenye sehemu expansion of solid tunasema kwamba expansion ya solid substance yenyewe inakuwaga ni very small, inakuwaga ni kidogo zaidi, such that it is difficult to observe this change, kwamba kiasi ambacho inakuwa ni ngumu kuweza kuobserve kwamba hii substance ambayo ni solid imeongezeka volume au imepungua volume. That's why tunasema kwamba the expansion, kuongezeka kwa kitu solid substance, whenever we apply a certain heat, it is very difficult to observe by naked eye that there is increase in just volume for some species. So as the temperature of solid increase, whenever the temperature of the solid material increase, the atom vibrate. An atom starting vibrating. Once the atoms of that solid material start vibrating with a large amplitude and the average separations between them increase. So the distance between those two particles increase. Whenever we apply heat on solid material, the distance between two atoms or two particles tend to increase. As a result, the entire solid occupy a large volume, ambacho kinachopelekea ni kwamba solid substance yote inakuwa imeoccupy au imechukua volume. As the temperature increase, so the solid substance particles tend to increase their volume due to the increase in the temperature. Okay, this can be seen in the Bose and the Ling experiments shown in the figure below. So consider this diagram. Once you see this is a ball and rings apparatus. This is a ball and ring apparatus. This is the retro distance one. This is the metal rings. This is the metal ball, and this is the metal ring. So here you can see the metal rings size yake ni hii hapa. Whenever we increase the temperature, size yake ita tend to increase. So here you can see this is a metal ball. Yes, this is a metal rings, and this is a retro distance. Observations and explanations from the previous diagram, like here, that shows the metal rings, metal balls, it have explanations about that observed. Which one? The first one, the metal ball can just pass through the rings at room temperature. This metal ball can pass these rings at room temperature. At room temperature, hii metal ball inapita kwenye ring pap, kwa sababu room temperature is always about 25 degrees of centigrade, especially in this Tanzania region and other African countries. And on heatings, wakati ambapo tutafanya heating, tutachemsha, anasema the metal ball expand, kwamba ile metal ball itafanyaje? Itaongezeka. When the metal ball expand, there is an increase in volume. Volume yake itaongezeka, and the ball cannot pass through the rings. Kwa maana hiyo sasa, these metal balls cannot pass these rings. Kwamba tukipiga tukiongeza temperature au tukahiti metal ball, maana yake volume yake itaongezeka. So volume yake ikiongezeka, hiyo metal ball haiwezi ikapita kwenye hii metal rings. Kwa hiyo kwa mantiki hiyo ni kwamba on cooling, wakati ambapo tutasema sasa tunapoza, contractions occur. Tukipoza, contractions inatokea, contraction. Ile contraction ikitokea, the original volume is regained, kwamba ile original volume ya ile metal ball inarudi awali. So the regains of the original volume of the metal ball, the ball can now pass through the rings. Kwa maana hiyo sasa, balls can pass through the rings. So you can see here, the ball can pass through the rings. Then, after looking observation explanations, let us go and looking something known as linear expansivity or coefficients of linear expansion. So once we're discussing about the linear expansivity or coefficients of linear expansion, is the ratio of increase in length to its original length per degrees raising temperature. So ratio ya increase in length, ratio ya kuongezeka kwa length to its original length, kugawanya kwa original length yake times degrees or changes in temperature is what we call the linear expansivity or coefficient of linear expansions. Kwa hiyo kiwango cha utaka kujua labda coefficients of linear expansion ni sawasawa na mtu aseme is the change in length divided by original length and change in temperature. So lazima uwe na final temperature and initial temperature. The same apply, lazima uwe na original length times and the change in length or increase length. Or is the increase in length by unit length of substance when it is temperature rise by 1 degrees of Celsius or Kelvin. So as a unit of linear expansivity is a reciprocal of Kelvin. Reciprocal of Kelvin is the SI unit of linear expansivity. So you can see mathematical linear expansivity is the increase in length divided by original length times the rising in temperature. So alpha stands for linear expansivity. Change in temperature is equal to bracket theta 2 minus theta 1. That means the rise in temperature. Change 2 is the initial temperature. Change 1 is the final temperature. Change in L is the length 2 minus the length 1. Increase in temperature. L1 is the original length. L2 is the new length. So here is the linear expansivity of different substance. So in different substance, there is a various linear expansivity. So this one have its own linear expansivity, this substance have its linear expansivity, and so on and so on. So you can see here aluminium. Aluminium linear expansivity yake ni 225.5 times 10 negative 6. So this is the linear expansivity of aluminium. The brass is 18.9 times 10 negative 6. Copper 7 times 1 10 negative 6. Irons 10.2 times 10 negative 1 from times 1 negative 6. Steel is 10.5. Glass 8.5. Pyrex glass is 3, and linear and invar is 0.9. So from here is just mark the end of our discussions concerning about the concept of thermal expansions and the expansions of solid material, or linear or thermal expansion of solid material. So my dear student, let us come to see the task here. Okay, our task is explain the concept of boring apparatus. We have discussing about boring apparatus, so you can pass and read what are the concept behind of the boring apparatus. Thank you for watching Educare TZ. Welcome for the next periods. My name is Sasun.
Purchase your tracks today.